This is part 2 of the video where I answer all the questions from the review. So I'm going to start with this page here. On this one, you were actually asked, you don't see the instructions, but you're asked to sketch a graph based on the domain and the range that were given. Now, in this problem, your answers are going to vary. So on this first one, I've given 2 examples that would work. What you need to understand primarily, and let me just zoom in on this one, is that the domain goes from -3 to 5, where -3 and 5 are both included in the domain, so we have these brackets, and then the range is from 1 to 4. So down here on the domain, you can see in the blue one, we have a point at -3, +1, 1 being the low point of the range, and -3 being the least or the farthest point to the left of the domain. And then it travels all the way over and includes everything over to 5 for the domain and 4 for the range. So it takes care of both of these requirements. Both are shaded on the end. So this blue graph would be an answer that would work, and so would this green one that I drew. It has a low point at 1, and it touches, so it's included, and it goes up to 4. So same thing, okay? So you can see some examples of these other ones here. I really think that this one is supposed to be, this is supposed to have a bracket on the 5 because I don't know how the 4 can be included. Well, there's different ways we could draw this, but you can see on this one that it goes to -infinity on the domain, and it goes up to the 5, but the 5 is not to be included. So it would not actually touch the 5, it would just approach the 5. So yeah. And then let's go ahead, let's take a look at this one for sure as well. This one, you have a domain of -2 to 3. So here on the x-axis from -2 over to 3, you can see I have a point that has the farthest to the left is the -2. It's open circle, so that's where the parentheses comes in. Then it travels over to the right at 3, and that's an open circle, so there's a parentheses there. And then also the range is from -1 to 5. So you can see my low point is at, oh, you know what? That's a bad drawing. It should come all the way down to -1. So let me go ahead and fix that. That should be, we should have an open circle, or I should have an open circle at -1, +5. So I could put that here, and that line would be drawn more like this, all right? So now you can see that the range is from -1 up to 5, but the -1 and the 5 are not included, so you have the open circles at the end. So that would satisfy this domain and range. And then this last one over here. So on this one, you have a domain of -3 to infinity, where both of them are not included. So you can see here on the -3 x value, there's an open circle. And this graph goes up and then back down and then continues constant here to infinity. But on the range, it goes from a -4 with an open circle because it's not included up to, and it touches the 2, the y value of 2, and you can see that's the bracket right there. So this graph would satisfy that domain and range, okay? Now let's move on from that section. All right, this is a section that we looked at in class, the last class before this review day, so last Thursday and Friday. This one wants you to state the domain of each function in both interval and inequality notation. So what we know, without actually graphing this, that this is the parent function, or this is the rational function, okay? Where you have your numerator and denominator, such as 1 over x. And we know when we do that, that the x cannot be equal to 0. Remember the parent function, 1 over x. And we know that we can't make x equal 0 because 1 equals 0 is undefined. Okay, so we can't make x equal 0. So what we do is we take our denominator, our 8x plus 6, and we set it equal to 0, and we work out the equation. So I've written it here. 8x plus 16 equals 0, so 8x equals -16. I just subtracted 16 from both sides, and then I divided by 8, and I got -2. So now I know x cannot equal -2, because if I plug in a -2, that would make that equal to 0. Well, I can plug in anything else I want except for -2. So to put the domain, I go from -8 all the way over to -2, and then I have a union, and I go from -2 to positive infinity, all right? And because I'm using these parentheses, I understand that that -2 is not part of the domain. Now, if I were writing an inequality notation, I would just say x less than -2 or x greater than -2. That's one way to write an inequality notation. This would be another way with a union. We could do our x is greater than -infinity and less than -2, and then a union with the domain is greater than -2 but less than infinity. All right, so both A and B would be inequality notation for that function, okay? This example over here is very similar. I just set 4x minus 4 equal to 0, and I solved it. So x equals 1. That means with this parent function, this rational function, I can't plug in a 1 because 4 times 1 would be 4, and then 4 minus 4 is 0. So this shows, again, just like this one, that we can use everything but 1. All real numbers except for 1 for that function. Now this one is a little different, okay? This one is the square root function. Remember that we can find the square root of 0, and we can find the square root of positive numbers, but we can't find the square root of negative numbers. So what we're gonna do then is we're gonna take the radicand, we're gonna take this expression underneath the radical symbol, x minus 5, and set it greater to or equal to 0, or greater than or equal to 0, and just solve that inequality. We add 5 to both sides, and we realize that x has to be greater than or equal to 5. You plug in a 5 in here, subtract 5, you get 0, and the square root of 0 is 0, and then it's going to be everything greater than that you can plug in. So here's the interval notation, from 5 to infinity. So we use a bracket because you can use 5 and then out to infinity. And inequality notation is very simple. X is greater than or equal to 5. Okay, this last one's a little bit tricky. It's kind of a combination. It's really a rational function. It's 1 over the square root of 5x plus 25. So because it's rational, though, I set it equal to 0. I work out the equation, and I realize x cannot equal -5. So to write it in interval notation, since that has the square root, we can use -5, but everything greater than that. So our interval notation is from -5 to positive infinity. Or in inequality notation, we could say x is greater than -5. All right, let's take a look at the last page. So taking a look at this graph, I want to show you, I've highlighted here different parts of this graph. This is the part where we could say that this graph is increasing. This is the interval in which it is increasing, and so is this right here. And this interval that's not highlighted, this is where it is decreasing. So you're going to need to understand interval notation in where the graph is increasing or where it is decreasing. And then you're also going to understand the interval in which the graph is positive, or the function is positive. So all of these numbers here that are above the x-axis, or negative where they're below. So let's just take a look specifically at the questions on the review. So this first one says, state the domain and range of the graph in both interval and inequality notation. So this is just the review of domain and range. The domain is from 0 to 5, and it's solid lines. So that's in interval notations, it's the brackets 0 to 5, both in brackets. The range from low to high, that's -3 all the way up to +2. So -3 to 2 in brackets. And then this is just inequality notation that says the same thing. Now over here, it's a little different. Determine the intervals of increase and decrease. Okay, the interval of decrease, again, is where I've highlighted. So you can see it's increasing from 0 to 1. Now, we don't consider this point where it starts as increasing or decreasing, just where it's going up, and definitely not where it levels off here. This is considered constant. So we would say from 0 to 1 is this part of the interval that's increasing, and then we have a union with 4 over to 5. So 4 to 5 would be our interval of increasing. Now our interval of decreasing then is this part where it's not highlighted, and it's going from 1 down to the 4. And again, these points where it levels off and turns direction, that's considered constant, and this is considered constant. So we use parentheses from 1 to 4, 1 to 4. That will be our interval of decreasing. All right, and you will definitely need to know that for the test as well. All right, so now this one says determine the domain and range of the graph where it's positive and negative. All right, and then this question says what is the absolute maximum minimum value? So let's just take a look at the positive and negative portion of the graph. Let's answer these two questions. So let me shrink this so we can see the question again, or see the graph. All right, the interval or the part of the domain on the graph that is positive is, again, this part here. So it's going from 0 to 2. So we write 0 to 2. Now the 0, the value, the function, when the x is 0, the y value is 1. So that's included in the positives from 0 to 2. But now 2, the outcome of 2, or the y, is 0, and 0 is not considered positive or negative. So at the 2, we just use the parentheses. And then the negative interval of the graph is everything below the x-axis. So it's from 2 over to 5, from 2 to 5. The 5 has the brackets because it's at 5, negative 2, and negative 2 is part of course, the negative part of the graph, okay? Let's see, and then we have what is the absolute maximum and minimum values of these graph? Okay, well, the maximum value is the high point, and the high point is at 2. It's technically at 1, 2. X is 1 and y is 2. So this is just listed as an x and y. This is not an interval notation. And the minimum, same thing, it's this point right here. That's at 4, negative 3. So 4, negative 3, that's the x and y value. All right. And then you'll see here this question, and I do need to zoom in a little, or let me slide this up. This says find f of 5. So on the graph, if you go where x is 5, you see that the y value is negative 2. So f of 5 would be negative 2. And then find f of 2, same thing. You go to the graph at 2 and you see that the y is 0, so that answer would be 0. We're just looking for the x and y ordered pairs for that section. Now this last question is a little bit different. It says find the value of x for which f of x equals negative 2. Well, that's when you look at your graph and you're looking at where the y is at negative 2, and that's right here. So this is saying the y equals negative 2. Well, when y is negative 2, the x is 3, so the value would be 3. All right, and that is a look at the review. Hopefully this helps. Please come to class with any questions about the review before we test. Thank you.